Having configured RETScreen for this analysis, let's turn to the Energy tab and start by specifying the electrical load and the base case power system for meeting that load, that is the diesel-powered generator. To review, the electrical requirements are 6 kilowatt hours per day of AC electricity with expected peak of 10 kilowatts, and the system must provide power a minimum of 8 hours per day. If we don't do a photovoltaic system, then the base case would be a diesel-powered generator. Diesel fuel costs $4.80 US per gallon delivered to this site. That's a little over $1.25 per liter. We're going to need to be able to supply the peak load with the diesel-powered generator, so we will size it at 10 kilowatts. A diesel-powered generator for prime power operations might run around $10,000 US installed. You can find cheaper generators. They're typically for standby or backup operations, which don't have the same lifetime as a prime powered diesel generator. I'm going to assume that maintenance will cost around $400 per year. That's for changing oil filters, changing oil, changing air filters, things like that. It operates around 3,000 hours per year, so I'm assuming that it's only going to operate 8 hours per day. And its typical lifetime is 20,000 hours. Now that's a typical lifetime under ideal operating conditions, and these aren't ideal because our load, our average load, is going to be very low. We have a 10 kilowatt diesel generator and 6 kilowatt hours per day AC average load. If the average load is extremely low, this will lead to a shortened lifetime. However, we're going to assume that it's going to last that 20,000 hours, and the replacement cost is going to be $8,000 US. The difference compared with the initial cost is that we will already have all the balance of system in place, so we just have to take out the old generator and drop in the new one. Concerns are, as I mentioned, the low average loading level will affect the longevity and will also affect the efficiency. It'll be very inefficient. However, we're going to ignore these two things. We're going to see if we can draw a strong conclusion about the photovoltaic system, assuming the best case for the diesel power generator. If we can make the conclusion that the photovoltaic system is better, then that conclusion would stand even under more realistic circumstances of the longevity and the efficiency of the diesel-powered generator being worse due to the low loading level. Turning to the Energy tab, we see that there's a lot going on here. Fortunately, the items on this menu ribbon are indicated or labeled Step 1, Step 2, Step 3, Step 4. So that gives us some guidance of how to proceed. And we'll note as well that the items on this label, there's a strong correspondence with the items on this navigation pane. In fact, they appear more or less identical right now, except for items here where we find the plus sign. So that's how we can add additional items to this. For instance, the proposed case here, if we want to add an inverter and battery, we click on that one, it'll add a line to this proposed case here. So let's then go to Step 1 here, click on Electricity and Fuels. It turns out we're already there. The fuel that's currently by default in RETScreen available is natural gas. We have no need for natural gas, so we could either leave it in and ignore it, or we could change it to a fuel that we do need, and one fuel we do need is diesel, number 2, and we're dealing with diesel in the units of gallons, so I'll click that, and I will put in the cost for diesel. It's $4.80 US per gallon. If I wanted to add further fuels, I could click on this plus sign here, and other fuels could be added, but we don't need any other fuel. So I'll delete that. And if you want to see a little bit more information about the fuel, you can click on this down arrow here and see its heating value and the fuel rate in terms of US dollars per kilowatt hour of energy in the fuel. That might seem like a bit of a strange way to look at it, but it allows us to use a common unit kilowatt hours for many different types of fuels and compare the cost of energy contained in that fuel across a range of fuels. We don't need to do that here. Electricity is here. This is for electricity from the grid. We don't have grid electricity available at this site, presumably. That's why we're doing an off-grid system. But I can't make this go away, so I'll just ignore it. It's not going to play any role in our analysis. The next step then is to go to the power system and load characteristics. So I'll navigate to that by clicking on that item in the navigation pane here. I see that we have here the base case power system. So presumably this is where I enter the characteristics of my diesel-fired generator. And then below that, the load characteristics for both the base case and the proposed case. So let's fill that out. For the technology, we have these options that I mentioned in the initial presentation: grid electricity, reciprocating engine, gas turbine, or other. So I'm going to leave that on reciprocating engine, which could be either a diesel or a natural gas or a gasoline fired generator. Here we have only one option because we've only defined one fuel. If we had other fuels, we could find them here, but that's the only fuel we've defined, so there it's assuming we're going to use that. For the capacity, it's a 10 kilowatt unit. This is a gray cell. Gray cells are there for informational purposes only. So I could enter anything there and it wouldn't affect the calculations. Red screen doesn't need to know the size of the reciprocating engine for the calculations. It does. It's a simplified model. Here we come to something a little bit more difficult to enter. It's the heat rate. So that's the kilojoules of fuel energy required to generate 1 kilowatt hour of electricity. And we can also specify that in terms of the British thermal units, or BTUs, of fuel energy required to generate 1 kilowatt hour of electricity. There's two ways to get this, or at least two ways to get this. One is to find the fuel consumption of the generator, say in gallons per hour, and convert that into gallons per kilowatt hour, and then convert the gallons of fuel into kilojoules of energy contained in that fuel. So then that would be a way to get to the heat rate. Here we have another option. We can hover on the heat rate text here, and you'll see this little question mark appears. If I click, help opens, and there's a description of what this heat rate means and the conditions under which it's measured. So there is actually some genuinely helpful information here, as well as some tables that might help us select typical heat rates for different types of equipment. And here's for reciprocating engines, less than 6 megawatts, the higher heating value, which is what I'm going to use here because that's what I selected in the settings, or what was selected in the settings, and you can go back and verify that if you want. So here is the table that appears, or rather the graph that appears. You can see the size of our diesel generator, or our reciprocating engine, is across the horizontal axis here, and the heat rate is on the vertical axis. So you can see that our 10 kilowatt diesel generator is going to be right at the very far left here. So something around 13,000 kilojoules per kilowatt hour. And if you actually look up typical, so I'll enter that there. If you look up typical values for consumption of fuel for a 10 kilowatt generator and do that conversion that I found, that I mentioned, you will find that it works out to about 13,000. The annual O&M costs are the annual operation and maintenance costs. These do not account for replacement of the diesel genset. They just correspond to the $400 per year that we are going to pay in order to keep it in good operating order. The next part is the load characteristics here. We are given cells for entering the base case and the proposed case electricity requirement, both DC and AC. We don't have a DC electricity requirement. We only have an AC requirement, so I'm going to leave these cells blank. And for our analysis, the electricity requirement is the same in both the base case and the proposed case. So I'll enter that 6 kilowatt hours per day here for both. Finally, there's this intermittent resource load correlation. So this is only applicable in the proposed case, and it allows us to specify whether there is a correlation between the availability of renewable energy in the proposed case and the load. So for instance, for solar energy, if we had a lighting load that was only on at nighttime, then the correlation would be obviously negative because the load comes on when there's no solar energy available. Conversely, if it was a ventilation fan that only turned on when there was strong solar radiation, or that only turned on when there was solar radiation, that would be positive. Here we can probably assume that the loads are going to be a mix of daytime, nighttime loads, so we're going to use 0, indicating no correlation between the two. And with that, we have a summary here of the annual load in both the base case and the proposed case. There's no difference between them because we haven't changed the load from the base case to the proposed case. So over here there's some incremental initial costs that we could enter if there was some sort of project that we did as part of this. A sub part of this project was, efficiency or other measures that led to a decrease or an increase in the proposed case electricity consumption. However, no such projects are envisaged here, so I'm just going to leave those blank. 0 cost is assumed there. Finally, there's this peak load on an annual basis. This is the 10 kilowatt peak load we've been told to expect, so I'll enter that there. We skipped over a few things. Up here, the most important of the things we skipped is the method. So you will see method 1 and method 2 and even method 3 buttons at various points in RETScreen. They allow us to select whether we do a simplified analysis with method 1 or a more detailed analysis with method 2 or a yet more detailed analysis with method 3. So in this particular screen here, if I select method 2, it will allow me to specify our load not just in terms of the total load, but line by line different items. So I could say, well, I have part of my load due to a water pump, and I could indicate whether that's AC or DC, the intermittent resource load correlation, what the power of the load is, how many hours per day it's used, days per week, etc. And then I can add another line, and I can build out my load from line items that way, and then it will sum those up and provide me with a total load there. However, that's not necessary here, so I'm just going to go back to method 1. Over here, there's also a little button. If our load is water pumping, we can click that, and it brings up a form for estimating water pumping loads. And finally, there's a % of month used here. If our system is only going to be used during certain months of the year, we can select this and specify that. Now, having specified the load in the base case and the proposed case, as well as the details of the base case power system, that is the diesel-fired genset, we can, in the next video, move on to specifying the inverter and battery of the photovoltaic system.